In this question, we're looking at transformations. In part A, we have triangle ABC, and it has moved to triangle DEF. We can see that the triangle has turned onto its side. So this is a rotation, and the direction is anti-clockwise. And because it's turned on its side, we know that the angle is 90 degrees. So we have a rotation 90 degrees anti-clockwise. There are 3 marks available. So far, rotation will score us 1, and 90 degrees anti-clockwise will score us another 1. To get all the marks, we have to write down the center of rotation. The best way of doing this is to ask for tracing paper when you're in an exam. Place the tracing paper on the original triangle, put your pencil where you think the center is, turn the paper and see if the triangle fits, and play around with that. If you don't have tracing paper, then you look at the shapes, and if you think you know what the center of rotation might be, so in this one maybe 0, 0, then you can join a point to that center and then join the center to the new position of that point, because the point C is rotated to that new position. You can see the angle between them is 90 degrees, and so long as the lengths of the 2 lines are the same, then the center will be in the correct position. So we can see as we move from this point to the center, we go down 4 and across 2, and if we move from the center to the new position of the point, we go along 4 and up 2. So the 2 lines are the same length, and the center of rotation will be 0, 0. So we can write about 0, 0. Moving on to part B, we're now being asked to look at triangle ABC, but this time it has moved to triangle GHU. We can see that the triangle has turned upside down, so we assume it's most likely a reflection. If we join a point to its new position and then find halfway along that line, and then do the same for another point, and the halfway point for that line is marked, then we can join those 2 points, and that will show us what the line of reflection is. So in this question, we have a reflection, and we can see that the line of reflection is the x-axis, so we can write a reflection in the x-axis, or if you want to use an actual equation, all the way along the x-axis, the value of y equals 0. So the equation of the x-axis is y equals 0. So you could write that instead of x-axis. And finally, part C. So, are the 2 triangles congruent? Sunil disagrees and thinks that all 3 triangles are congruent. So if you look at all 3 triangles, you can actually see that each of them has one side that is 4 units, and then if you look at the shorter of the remaining sides, you can see quite easily that they are all of equal length. And then the third side you could measure, or you could count squares across and up for each one, and this will confirm that this side is also equal. So Sunil is correct. All three triangles are congruent. And the reason is all three sides are the same for each triangle. So congruent because all three sides are equal. And the condition for congruent triangles, there are four of them, and one of them is SSS, side, side, side. So Sunil is most definitely correct.